This is Appendix D, page 3, and we're going to continue graphing, and this part of this section is on translations. This is where we're going to shift the graphs up or down, and then to the left or to the right. So let's start off by working on example 5, where we graph the basic function f of x is equal to x squared. So we've already graphed this before, and we saw that -1, 0, and 1 were not quite enough, so I'm going to go -2, -1, 0, 1, and 2. If we plug in -2 and square that, we get 4. Plug in -1 for x, we square -1, we get 1, square 0, 1, and then 4 is 2 squared. And let's plot the points. And you can see that the graph is a parabola. For the next graph, we have an x squared plus 2. So we can use our previous table to find the values of y in this table, because do you see how the only difference between these two equations is that here we just have the x squared and here we have x squared plus 2. So that means I'm just taking these y values and adding 2 to them. So when x was -2, y was 4. Well, 4 plus 2 is 6. And then taking this 1 plus 2 is 3. 0 plus 2 is 2. 1 plus 2 is 3, and 4 plus 2 is 6. If that's a little confusing, you can just go ahead and plug in the numbers again for x and solve for y, and you'll get these y values. Let's plot the points. And you see when we draw this graph, oops, it has the same shape as the original one, but do you see how it shifted up by 2? So what we just graphed was the basic function, and then this plus 2 shifted it up 2 units. So can you guess what the next graph is going to look like? We're just taking the original function and then we're shifting it down by 3 because it's -3. This will be shifted down by 3. Let's see if we can do this with the original graph without making a table. So if we start off with our first point, I'm going to start with a vertex. We had 0, 0. I'm going to shift that down by 3 units. If we have the same shape as the original one, do you see how we are going to the left 1 and up 1? And we go to the right 1 and up 1. And then to get to the next point, we went to the left 2, and we squared that to get 4, so up 4. And if we go from the vertex to the right 2, we go up 4. And we've got the new graph. So hopefully you remember doing this before. We're going to do the same thing with trig functions in a little bit. So for every point on a graph of f, if we add a c to that, then the y is being shifted up by that c. So that'd be y plus c. And so if c is positive, then it's translated up. And if it's the absolute value of c units, it's going to go down if c is negative. The graph of g is a vertical translation of the graph of f. Now let's try translating a graph horizontally. So we're taking this same basic function, f of x is equal to x squared, and I'll go ahead and make another table here. I'm just going to copy the one that I have up there. Now, for the next one, do you see how there's an x minus 1 inside the parentheses? So that -1 is something that's different than the first one. So I'm going to keep the y's the same. I want 4, 1, 0, 1, and 4, and figure out what my x's have to be to get those values. So if I wanted 0, do you see how x would have to be 1? And if I wanted it to be 1, the y to be 1, then x would have to be 2, because 2 minus 1 squared is 1. And then if I want it to be 4, do you see how x has to be 3? Because if we go 3 minus 1, that's 2. 2 squared gives us the 4. Now, if I want to go in the opposite direction, do you see how if I put 0 here, 0 in for x, then we have negative 1 squared, which is positive 1. And then I could plug in a negative 1 for x, because negative 1 minus 1 is negative 2 squared gives us 4. Now that seems a bit complicated, but you'll see why I did this in just a minute. So let's plot the points. And if we compare the two graphs, do you see how this is a shift to the right by 1 unit, comparing this to the original graph? So this is, because of this minus 1, this is shifted to the right by 1 unit. So can you guess how this last one here is going to be shifted if we have x plus 4 squared? Well, then the plus 4 means it's going to be shifted in the opposite direction. It'll be shifted to the left by 4 units. So starting with the vertex, we're going to the left by 4 units. But it has the same shape. So when we square 1, we get 1. When we square 2, we get 4. So I'm just copying the same shape as I had from the original one. And then using symmetry, we can just go straight across and then draw the graph. So you see how when you have a number inside the parentheses here, it's shifted to the left or to the right. So for horizontal translations, if you have a point xy that's on the original graph f, then x plus c, y will be on the graph of g, where we have f of x minus c. So you see how you're doing just the opposite. So going back up here, we had x minus 1. It shifted to the right by 1. X plus 4 shifted to the left by 4. So it's just, you're going the opposite direction of what you think it should be. And so if c is positive, this is a little tricky. If c is positive, it's going to the right because it's x minus c. Or if c is negative, it's going absolute value c units to the left. And that's all because there's a minus c in there. So you can see that it's minus c. For the vertical translations, we had a plus c. So the graph of g is a horizontal translation of the graph of f. Now let's combine what we just learned. For the first one, do you see how there's a negative in front of the x squared term? So our basic function is f of x equals x squared, which is a parabola, and we drew that many times. Then the negative that's in front of it will reflect the graph across the x-axis. So let's write that here. So this negative reflects across x-axis. And then the minus 1 will shift it to the right by 1. So shift right 1 unit. And then the plus 4, it's a positive 4, so that means that it shifts up by 4 units. So let's start off by finding the vertex. All you do is let's go to the right 1 unit from the origin. So to the right 1 unit, and then we go up 4 units. Now instead of opening upward, it's going to open downward because it reflects across the x-axis. So our vertex, instead of being the lowest point, is going to be the highest point. So when I square 1, I get 1, but because there's a negative in front of that, it goes down. 2 squared is 4, but we're going in the opposite direction because we have a negative in front of it. And then we can use symmetry to draw the two other points. Now, if you prefer to draw the basic function first, you can do that. So let me back up a little bit. If you were having trouble with understanding that, we can think of the original function f of x equals x squared as a parabola that opens upward, but then the negative means it would open downward. So I can just draw, I'll just draw a really rough sketch here. Let's make it dotted. Oops. So this is before the translation, and then we shift it over 1 and then up 4, and that's the final translation. For the second one, we have a -2. So that's going to do two things. The negative will reflect it across the x-axis. The 2 is going to make it steeper, so this is going to stretch it vertically. And then the +3 is going to shift it to the left by 3 because it's inside of the absolute value. Now we could draw several graphs to get to that point. What I'll do is I'll start off by taking care of the reflection and this vertical stretch. So let's think of what the absolute value function looks like. It's a V shape. The negative in front will make it reflect across the x-axis, so it's going to open downward, and the 2 will stretch it. So we start off at 0, 0. Now this is before we translate it. And then when I go over 1, instead of going up 1, we're going to go down 2 because of that -2. And normally we would go over 2, up 2, but now we're going to go down 4. And then we can use symmetry to plot the other 2 points. Now this is not the final graph, so I'll just make this dotted. Now let's shift it to the left by 3. So I have this new graph. I'm going over 1, down 2, back 1, down 2, over 2, from the vertex down 4, and then back 2, down 4. So we use the basic function f of x equals the absolute value of x, it's V-shaped. We reflected across the x-axis because of the negative, stretched it vertically because of the 2, and then we shifted it to the left by 3. The last one, let's see, we've got this 1/2. So the 1/2 will compress it vertically. So compress vertically. So this is a square root function. So we're just going to take those y values and take half of them. And then the +2 means it's going to shift to the right. Ooh, nope, shift to the left by 2 units. And then the -3 will shift down by 3 units. So let's start off with the square root function, and I'll write a few of these just to help you along. So if we start off with the f of x is equal to the square root of x, then we'll start off with 0, 0, square root of 1 is 1, and square root of 4 is 2. I'll make this dotted. Now we compress this vertically, so that means that all the y values are going to be cut in half. So for the second one, we're going to have 0, 0, because half of 0, 0, 1, 1/2, and then 4, 1. So I'm just cutting those y values in half. It's my new one. Then we're shifting it to the left by 2 and down by 3. So I'm going to do 2 things at once. So taking our first point to the left by 2 and then down by 3. Now I'm going to have the same shape. So if I go over 1, up 1/2, from the original point, I go over 4, up 1, and then we've got the graph.